Description of the defrosting procedure. General overview: the freeze dryer defrosting procedure is key to keeping the equipment running well. It removes ice or frost that builds up, ensuring the freeze dryer works right and avoids problems. Freeze dryers can defrost manually or automatically, depending on the model. It's important to take out any product before defrosting starts. The defrosting procedure involves several steps that must be followed to ensure the freeze dryer is adequately maintained. This process can be performed manually or automatically, depending on the equipment's capabilities. Key steps involve unloading the product, checking utility requirements, setting parameters, starting the defrosting cycle, monitoring the process, verifying completion, checks and precautions before defrosting. Before defrosting, check if you have clean steam and that all valves are set right. This makes defrosting go smoothly and avoids issues. Look over the freeze dryer and its parts to see what needs extra care during defrosting. This helps avoid damage and make sure defrosting works well. The time it takes to defrost depends on how much frost there is. Light frost takes 2-3 hours, moderate frost takes 4-5 hours, and heavy frost takes 6-8 hours. A freeze dryer has ice forming on its coils as it undergoes the defrosting process. The surrounding area should be well lit, with steam or water droplets visible in the air. The freezer's door should be slightly ajar, showing the interior. Unloading the product: ensure the product is unloaded from the chamber of the freeze dryer before starting the defrosting cycle. This step is critical to preventing contamination and damage to the product. Auto defrosting in recipes. If auto defrosting is selected in the freeze drying recipe, the condenser automatically gets defrosted during unloading. This feature guarantees consistent outcomes while streamlining the procedure. Here are 5 important points related to auto defrosting in recipes. Automatic condenser defrosting. When auto defrosting is selected in the freeze drying recipe, the condenser defrosts automatically during the unloading process, eliminating the need for manual defrosting. Consistent results. Auto defrosting ensures that each batch is processed under the same conditions, leading to consistent and reliable outcomes across multiple freeze drying cycles. Streamlined workflow. By automating the defrosting process, auto defrosting streamlines the freeze drying procedure, reducing downtime and increasing overall efficiency. Reduce labor. This feature minimizes the need for manual intervention, freeing up personnel to focus on other critical tasks and improving operational productivity. Enhanced equipment longevity. Regular and automatic defrosting prevents ice buildup in the condenser, reducing wear and tear on the equipment and potentially extending its lifespan. Ensuring clean steam availability: check the SCADA, supervisory control and data acquisition, system steam supply indication to make sure clean steam is available. Effective defrosting requires clean steam. Here are 6 important points related to ensuring clean steam availability. SCADA system monitoring. Regularly check the SCADA system's steam supply indication to ensure clean steam is available, which is crucial for maintaining process integrity. Effective defrosting. Clean steam is essential for effective defrosting in freeze-drying processes, ensuring that equipment operates efficiently and without contamination. Preventing contamination. Ensuring the availability of clean steam prevents contamination of the product, maintaining the quality and safety of pharmaceutical preparations. Consistent performance. Reliable access to clean steam ensures consistent performance of the freeze-drying equipment, leading to uniform results across different batches. Maintenance and inspections. Regular maintenance and inspections of the steam supply system help identify and address issues promptly, ensuring a continuous supply of clean steam. Operational efficiency. Ensuring clean steam availability optimizes the overall operational efficiency of the freeze-drying process, reducing downtime and enhancing productivity. Analyze the sample. Analyze the collected steam sample for quality parameters such as steam dryness, non-condensable gases, and superheat. Use appropriate methods and equipment for analysis. The steam dryness level needs to be at least 0.95, meaning 95% steam and 5% water. For laboratory autoclaves, a dryness level as low as 90% is still okay. If the steam is less than 90% dry, it is considered wet steam and not acceptable. Initial valve states ensure that the main isolation valve is closed and all valves are in their normal state before beginning the defrosting cycle. This precaution helps maintain system integrity. Utility requirements for defrosting compressed air. Make sure compressed air is supplied at a minimum pressure of 0.4 MPa. Compressed air is necessary for various pneumatic functions during the defrosting process. Chilled water. Chilled water should be available at not less than 1 kg cm2 This utility is crucial for cooling and maintaining appropriate temperatures during defrosting. Clean steam. Clean steam must be available ATA pressure of not less than 0.3 MPa. Steam plays a vital role in the defrosting process by providing the necessary heat. Nitrogen. Ensure nitrogen is available at not less than 0.3 MPa. Nitrogen is often used for venting and purging during the defrosting cycle. Utility requirement. Compressed air necessary for various pneumatic components and controls. Chilled water required for the condenser and refrigeration system cooling clean steam used. For temperature-controlled, heated shelves. During defrosting, nitrogen utilized for product chamber pressurization and inert atmosphere. Pre-defrosting checks healthy condition verification. Before starting the defrosting cycle, check that all start conditions are in a healthy state. This verification includes ensuring all systems and components are functioning correctly. Equipment readiness. Confirm that the freeze dryer is ready for the defrosting cycle. This readiness involves verifying that all parameters are set correctly and utilities are available. Frequency of defrosting post-freeze drying cycle. Defrosting of the freeze dryer condenser should occur after the completion of each freeze drying cycle. Regular defrosting helps maintain optimal performance. Periodic performance verification, PPV, and requalification, RQ, runs. In cases of periodic performance verification, PPV, or requalification, RQ, runs, or as per scheduled qualifications, a defrosting cycle should be performed. These runs ensure the freeze dryer operates within specified parameters. Detailed procedure for defrosting process, auto mode procedure. The auto mode procedure simplifies the defrosting process by automating many steps. Follow these guidelines for an efficient auto mode defrosting cycle. Auto mode defrosting steps parameter setting. Set the parameters for the defrosting cycle on your freeze dryer SCADA system. These parameters include temperature, time, and pressure set points. Starting the cycle. Start the defrosting cycle by entering the correct username and password on the SCADA system. This step initiates the automated process, monitoring and completion. Visually check the presence of ice on the condenser coil through the view glass during the auto defrosting cycle. Ensure the completion of the defrosting cycle by verifying the process finished message on the main SCADA screen. Parameter settings for defrosting. Temperature set points, condenser drain temperature, 90 to 96 degrees Celsius. Time set points, defrosting time, 15 to 20 minutes, drying time, 30 to 35 minutes, delayed after steam exhaust, 32 seconds, TBA drain time, 15 minutes, pressure set points, lower hysteresis of steam inlets, 12 MBAR upper hysteresis of steam inlets, 26 MBAR additional functions during defrosting venting gas options. Use nitrogen or air for venting gas during the defrosting process. These gases help maintain appropriate pressure and prevent contamination. Situational use is nitrogen, best for high-stakes environments where contamination must be avoided. Air, compressed air, suitable for less critical applications where cost is a concern. Visual inspection during defrosting, monitoring ice presence. Check for the presence of ice on the condenser coil through the view glass. This visual inspection ensures the defrosting process is proceeding correctly, ensuring cycle completion. Verify the completion of the defrosting cycle by confirming the process finished message on the SCADA screen. This step ensures the cycle has concluded successfully. Post-defrosting verification batch report. Verification. Verify the batch report of the defrosting process, DFR. This report provides detailed information about the cycle and confirms its successful completion.